Hello friends, welcome to follow up. Let's have a look at problem 2549, count distinct numbers on board. So this is an easy problem. Actually, it's also today's daily challenge problem, similarity problem. So in this video, we're going to share some coding basics. So if you want to do this problem or solve it, so you can return, say, 0. So 1 if n equals 1. Otherwise, you just return n minus 1. So we'll explain why this works. So you can test that, and then it will pass all the cases. So now our main focus will be explain this and focusing on the digest for the requirement. So here we are given a positive integer m that is initially placed on board, and every day for this number of days, so you perform the following procedure. So for each number x present on the board, then you find all numbers in between 1 and n, both inclusive, such that the remainder of x divided by I is 1. And then we place those numbers on board. So we want to find the number of distinct integers present on board after a large number of days. So here, if you look at n equals 5, it's 4, right? If you look at n equals 3, so it's 2. So 1 less than the integer m. So this is the same as today's daily challenge problem. So today's daily challenge problem is, let me write that. It's problem number 1688, right? So with that said, let's look at the analysis here. So what we are going to do is this. Let's see. We can first see if n equals 1. So in this case, each day we want to find numbers that is between 1 and 1. That is 1, right? So 1, and so just itself, because 1 divided by anything 1, this will be 0. So nothing will add it to the board. So a special case. So now let's look at the generic case. The general case. So for the general case, let's take one number as an example so that you can get a feeling. So for example, if n equals 6, right? So they have 5, we have 3. Let's look at 6. And then for day 1, let's see. So we want to find all the numbers on the board. So the current number on the board, numbers on the board is just 6. So here I'm using a set, right? Then I want to find I, such that 6 over modulo I is 1, right? So for this, if you look at the factors of 6, so you're going to get so 1, 2, 3, right? But if you look at 4, so this will give us remainder 0. But if you look at 4, the remainder will be 2. And 5, the remainder will be 1. And 6, the remainder will be 0, right? So in other words, we are going to add 5, right? So now in the board, we have 6 and 5. Notice that 5 is later added, right? So now let's look at day 2. So for all the numbers, we want to find those I such that the modulo operation will remain 1. Because we have already checked 6, so we don't need to do that operation, right? So we only need to consider for find I such that 5 over I equals 0. Not equals 0, equals 1. But if you see I equals 1, so you get remainder 0. 2, you get remainder 1. So this is okay, right? And then 3, the remainder 2, not okay. And 4 always gets remainder by 1. That's okay, right? And 5, remainder 0, right? So you are going to add 2 and 4, right? So anyway, we just noticed that at least 4 is added. So now on the board, what do we have? We have 6, 5, 4 is added, right? 2, let's see, just put it here, know that it's added. So then these 3, so we don't need to look at 6 and 5, but we just start from 4 and 2, right? So for number 4, so you can see I equals, see, if it's 1, it remains 0, 2 remains 0, 3 is okay, right? And 4, of course, it gives 0. So we're going to add at least 3, right? So if the number 2, right? So if see I equals 1, you get the remainder 0, 2, you get the remainder 0. So you get 2. So here you just have this one, nothing added. So on the board, so we're going to have, because 6, 5, 4 already and 2 already in. So now we added 3. So now let's look at 3, right? So this is default, right? Actually, this is not important. So we have already checked 6, 5, 4, 2. But actually, we don't need to pay too much attention to this. We can look at 3. So for the number 3, right? So we can see if I equals 1, it's not good. If 2 is okay, right? 3 for sure gives remainder 0. So it will be added. So then, so in this case, we know that we are going to add 2. But in this case, 2 is already in. So on the board, so we are going to have 6, 5, 4, 3, 2. And then if we continue, no matter how many days, no new number will be added. But each day we notice that at least, so here on day 1 we have 6, 5 is added. And then here 4 is added. And then this day 3 is added. So at least, so because the reason is that n given any number x, so x modulo, let's see, x minus 1. So you get a remainder, say 1. So assume that x are positive integers, right? So, but this gives us a stop condition. But notice that if you have 2, so you are going to stop, right? So given any n, so as long as time is sufficient, so actually you can compute that even. But for this problem, n is very small, it's 100, right? So as long as you have 99 days, that will be sufficient. You get the number. So as long as it's sufficient, you are going to get it's n minus 1, then up to 2, no more. So this from 2 to n is n minus 1 numbers. But the special case is n equals 1, right? You just have 1 itself. So here, this part explains if we do return like this will work. But now we want to, because here is a coding exercise, I want to share some coding basics. So let's see, we can copy this line. I want to demonstrate the use of set, right? So we can think of this as a large number. So, right? So here n is relatively small, right? It's bounded by 100. So now what I want to do is originally on the board, so we have this number, right? Numbers on the board. So then what we are going to do, so I'm going to use a flag. This is just to use as a stop variable. So while flag, we are going to do the following. Then we are going to see what we can add using the the set. And then what we want to do is that for x in say aux copy. So here, because I'm going to modify this dictionary, not dictionary, set, so I'm going to first use a copy of that. And then what I'm going to do is for I in range, so 1 and n plus 1. So this is fixed, for always is n, right? And then if x modulo I equals 1, we know that x modulo x minus 1 is always 1, right? But here, this coding is in some sense dummy. So what I'm going to do is to add this number to the current set, right? So now we are going to do check if current is subset of the aux, then it means that no matter what we're going to do, we cannot add more elements. So we're going to set the flag to be false. Then the while loop will be stopped. Otherwise, what I'm going to do is that, so we are going to do aux equals aux, use unit operation, unit the current, right? And then we can return the length of this set, right? So now let's do a test. It passes the 5, so I will expect it will pass all the general cases, but we want to check for n equals 1. Yeah, it passed n equals 1. Now let's look at the general case. Yeah, it passes, but it's slow. The reason is that we do a lot of redundant check. So for example, here we have this one, and so we can use a preset, right? So you have you just use each time if you want to see, you just see the newly added ones, right? For example, originally I start from 5, then 6, I add 5, and then on the second day I don't want to check 6, I just want to check the newly added one. So use that, you can modify the code a little bit, but our purpose is to demonstrate, the thinking of algorithm thinking. So, but if you want to solve this problem, you can use logic here. So I guess for today's daily challenge problem and this similar problem, so it's sort of like a brain teaser, right? So, but if you want to practice code, you can, for example, in this problem, you can practice the use of set, right? So with that said, I guess that's it for this video. Thank you.